in this series where I'm programming an NES game live on Twitch from scratch. Let's see, last time we left off, we were working with changing up the sprites so that when you run the game, it uses the bottom portion of the sprite created by Jordan, the artist who I'm working with here. So we've got the bottom part of our ship, which is cool. There were some issues we ran into, mostly related to the way the asset tool was working and exporting files. But that seems to have been taken care of. What I wanted to do today was to work a little bit on a couple of things. One was the exporting of sprites so that they have this information in a separate file to enable us to export the data from the command line without needing the editor. There's going to be probably a few little hiccups with that, but that's okay. We'll make it work. The other thing, well, maybe we won't get to the other thing. We'll see. Let's start with that. We had talked about doing some work with a definition of metasprite, which is a couple of sprites kind of put together as a single object in the game, but I'm trying to not be too crazy ambitious about what we do each stream, because otherwise they end up being like 4 hours long, which is too long for me and for you. So, all right, let's do this. So the first thing is, Jordan brought up the fact that we have the ability to use a command line to export things from a sprite, which is pretty cool. So that means that we can use a sprite to take the assets from the a sprite layered file and export the content. So in theory, what we should be able to do is something like this, right? And this will be important because we'll, again, kind of put this all as part of our build process, because like I was saying in previous streams, I really want it so that when you change individual assets in the game, it will trigger the rebuild of the relevant parts without any sort of manual steps. I want to get the main ship into the game and start playing around with some design ideas that I've had. I had some ideas about how I want the game to play. I definitely want the game to convey a sense of speed, in addition to sort of having the ship appear as if it were high up altitude-wise. And Jordan has done some really nice artwork that I may show, just kind of as like concept art for what we're doing here. But let's start with one thing at a time. So let's see. Options, files. So I should be able to take I just created this simple test sprite and should be able to save that as a PNG. So I should be able to say layer sprite, save as like that. Now there are two layers. There's a background layer and a sprite layer. What's nice is that you can automate the export of just the individual layer that you want to export by selecting it from the command line. Let's see. So I'm going to get rid of these two files that I had created while testing. Should be able to just run that. Okay, so it looks like I have to provide some provide some additional details here for it to do that. So let's see. Resize, export. Is there a way? Batch. That's what I want. So -B. And let's see what it did. All right, there's a PNG, and it looks like it's transparent, which is what I wanted. So that's pretty cool. That appears to have worked. Let me go open. No, not with Sublime Text. Paint is probably the best thing to open this in right now. So that has a white background. Let me see something here. Oh, come on. Sorry. I'm getting email notifications here because that's exactly what I need to be getting right now. All right. I believe yeah, so let's change this up a little bit, and obviously this is not very good, but it will do for the purposes of what we're testing here. Let's keep the transparency pretty obvious. Okay, we'll save that. Go back and export that, and let's see what that looks like now. Fine. All right, so it's exporting. Is it exporting that, or is that how Paint is interpreting it? Looks like it's exporting that. So, all right. Color mode indexed. The other thing we want to do is include transparency. Well, I mean, it should be. Is it maybe because the layer is case sensitive? No. Let's see. So, I mean, I'm assuming, yeah, so this is it just because the background isn't actually set to be transparent? No, it is. If I make this blue, okay. If I change the position, it should have no. So it is transparent. I guess I'm just not exporting it right. All right, so let's go back to the drawing board here. What did I... a Sprite export transparent. I feel like... I mean, if I go, let's do this. If I put it in match mode so it didn't pop up, but let's go look and see if there's a layers, visible layers, layer sprite. So I just wanted to do that, right? Overwrite the following. Yes. Yes. Is it just crappy rendering within the Windows views of what I'm looking at, where it's using white instead of transparent? If I open this with Photoshop, assuming that it will work, is that what the problem is? No. Yeah, okay. It is actually transparent, so it's just Windows not treating it properly as transparent. So that has, okay. So if I do this, oops, cancel. Let me close that. Put it back in batch mode. There's the PNG. Just real quick, reopen it with Photoshop. The reason I care about it keeping the transparencies is because at some point what we'll do is we'll key off of that for the palette 0 color. Yeah, okay, good. So that's working. All right. So that's good. And then from there, you can say NES asset tool, PNG to Sprite. Projects, shooter assets, PNG, test sprite dot PNG, and then I can open that up. Like I said, we'll make it so that it knows how to do that properly, but that's all good. We'll save that. And then in the project itself, I'll just let me replace this with that one. And then so that generated our exported data for the whole game. And we've swapped our bullets to be the new test sprite that we were using. So let's go back to this and build. Oh yeah, except it's not called that anymore, is it? Oh, what did I do? That's interesting. Why did it add explode twice? Assume this is the same. Yep. All right. Wait. Is it just a bug in the way it works? Why is it double? Huh. Oh, you know why? Because I had changed this, and I never changed the code. Never changed the code to properly handle that. So when it generates it, it's adding the .sprite file, but it, yeah, anyway. We'll fix that in a second. That was more so because it just felt weird that we were putting the PNG and it was figuring out the sprite file than just putting in the sprite file directly. So let's see. So all the places that reference bullet are going to be wrong, obviously, because that doesn't exist anymore. I don't think there are too many. Is that everything? Symbol player is undefined. Okay, so that built. So now the bullets should be replaced. Yep. Okay. And they look to have appropriate transparency. Okay, good. So that was all just to prove that we could do that by exporting that layer from a Sprite from the command line. Let's put the bullet stuff back. And let's fix the project. Just make sure it's really fixed. And then why is this ignoring when I tell it to run something? Okay. Also, what is going on with my computer? Why is this running so slow right now? It didn't really make much of a difference. I thought maybe turning off the preview in OBS would do something. Doesn't seem to matter. Okay, I don't know. It's just running not so great. Okay, we fixed that problem. Alright, so we've got our explode, our bullet, our player. Let's make these be sprites because this makes more sense, right? So if the token's a sprite, then add it to the list. Now, what we were doing after that is I believe we were checking to see if it's a sprite. Let's see. We were then adding an additional entry for it with the renamed extension. Yeah, which we don't need to do if it is a sprite already. If the type is sprite, let's see. Get the full path, check if it exists. Copy the entry and create a sprite. Okay, so if not is sprite, project files, file full path. So if for some reason we use .png, then it will do what it was doing before. Otherwise, it will skip this step so that it doesn't double generate like it was doing before. All right, so NES asset tool, that's in the base directory. Release. That was built here. Replace. All right, so now this says .sprite. Re-export. Let's look at this file here. No entity flyby. So now they're missing. Why are you missing? Oh. Let's do the same check here. We still have to increment these guys. So if file exists, project files, file full path. So only do this if the file exists. And this is just, actually we don't want to do that. We just want to add to the sprite ID and the export ID. We don't want to create the new file item entry there. All right, so replace that. Now let's see what it does. Let's try debugging this and see why a PNG file works, but this does not. Projects, shooter, assets, shooter.text. Alright, so the type is Sprite. So the full path is explode.sprite. So if the file exists, then increment the sprite ID. So do we care about the PNG? Oh, I guess we do, because... Well, why? Why would we care about the PNG? Is it using that reference to get information about the... It's just weird that it's doing that. Because let's see, so if we export the map, we load the map, and then we iterate through the files. So if it's a sprite, it's going to do this part, and then it's going to write some map data, and then palette data, and then some metatile character data. I don't see why it cares about PNGs at all at this point. Current item count is one more because we've added one to it. And then we are copying the full path and replacing it in temp. And then if it exists, we are modifying this to reference. So like what is... explode.sprite, explode.sprite. Okay, that looks good. Just out of curiosity, what does it look like from when I just did that? Okay, so it's just some weird quirk left over from the way the map export is working, I guess. Export map. Turning PNGs into sprites and probably metatiles when there's an existing file system item for that PNG adds an extra unnecessary. Was that doing that in here? Or is it doing it in load map? So, I mean, you know, all of this is basically the process of kind of unraveling the way that this tool was built a little bit and going back to, you know, why we did things the way we did them, and then fixing it to work with the project now that we have a clearer understanding of what it is we even want to do. Then copy the content of the object list so we can load it as a sprite. That can be challenging when you spend a lot of time kind of going back and forth between pieces and not working with it directly, you know, for an extended period of time. That's why it's so hard when you're doing something at work and you get interrupted. People think that, you know, you can multitask, and you kind of can, but ultimately being able to focus on working on one problem at a time without interruption is so much better for getting a solid solution than trying to multitask between a bunch of solutions. And I know sometimes it's hard because you kind of have no other choice. But that doesn't mean that it is a good solution to the problem of having a lot to do. All right, so these get added in. Are these replacing the existing sprites because we're not accounting for them somehow? This is a process where we take objects that were part of the map and we turn them into sprites because they are enemies that will appear. They're on the object layer of the map. Let's see. Map tile to file system item. Why? Why is it doing that for the gradient? Interesting. Because it has a GID of 1. Where's current file list coming from? That's our global. But if that's the case, why? Oh, well, that might be the problem. So the current file list should have had those sprites we loaded initially from the project file. So project file count, current item count plus plus. Oh. I see. So that's a little strange that we did it that way. I shouldn't collectively blame everybody. It's a little strange that I did it that way. But I think that explains it. So it's actually overwriting current file list 0, current file list 1. Current file list count. What did I call it? Current item count. Three, but I don't see any of those things in here. Let's see. Oh, I'm an idiot. Okay, all right. I know what the problem is because I got confused between the project files and the current file list. All right, sorry. So it's all right. So the problem is I was looking at this current file list thing, and or the project file list and the current file list, and kind of accidentally mixing up the two. So let's see. So the main thing is I want to, right. So it's just copying and adding to the current item count, and then it's assuming that it needs to add it as a sprite after that. So if not is sprite current file list I, and then this is dot file dot full path. So if it's not a dot sprite file, then we have to do this. Otherwise, that's fine. But we still need to increment those guys. That should fix it. There we go. Okay. So now if we put PNG, it will convert it to a sprite, or it will assume that you're talking about a sprite and use that. Otherwise, it will just use the sprite in the list like it should. And that built, and that worked, I think. Okay, cool. So now we have that working. Now what I want to be able to do is for something like the player sprite, where let me build the release version of, actually we don't need to do that for what we're doing here. So what I want to be able to do is now for something like the player sprite, right now, if you open it, you can look at the collision points, which are those green points there. We've got that extra one, which I don't care about right now. What I'd like to be able to do is, rather than require that to be configured through this user interface, just have a simple text file that we can use to provide that same kind of information for the conversion process. So something like the following: create a player dot, we'll call it meta, and so like I said, we would want to have all of the details of the sprite. I don't care about the version or the file name or the palette, but we would want to do, well, the width and the height. The width and the height we would want to be able to set, because the width and the height are potentially different than the, oh no, because we have frame width and height, never mind. So the width and the height we don't care about, because that's set from the actual image. The number of bounding boxes we do care about, so just trying to think what's the easiest way to, I mean, would it be worth using the JSON parser for this? Would be easy to follow, right? We could do bounding box count, or we don't even have to do that then. We could just have the bounding boxes and it could figure out, right? We could say bounding boxes, and then just have an array. Same thing with collision points. And is animated. You know what, we'll leave it if frame width and height don't exist, then it will just use the existing width and height. So it only matters if it's animated. So maybe we rename this to player.json. And then all right, so if it is a PNG to Sprite, we can look and see if our count is equal to 2, right? That would mean there's a third argument. String copy s target metadata max file folder name arg v3. And let's define that somewhere. Not target meet data, target metadata. Okay, so if we just do export, no, PNG to Sprite, we're obviously breaking this part, but that's okay. This is all fine. All right. So now if we want to take a look at what actually got generated. Right. Okay. So that is the ship. That's good. That's the old ship. So now what we want to do is what? We want to take the... I think I want to take the... I want to do a couple of things. I want to be able to take the existing sprite and export it to JSON so that we can use that as a template. Also, if we do visually set the collision points, it'll give us a way of exporting that out. So let's add a new action here. We'll call it else if. Do Sprite to JSON. Okay. Yeah, I know. Eventually we gotta fix that and actually put some usage. Not really important or super interesting to stream, so I'm not going to do that right now. And then tool action is convert. Say convert sprite JSON. So obviously that doesn't exist. Let's create that in the enum. Convert sprite JSON. Comma. Okay. So that's that, and then it's pretty straightforward. I don't know that it's even worth using Jasmine to generate the JSON because of how simple the structure, well, the structure might be. Let's take a look and see if there are any helper things that would, oh, so it's only a parser, so it doesn't generate. Okay, so never mind that. I forgot that. Else if tool action equals Sprite, no, what do they call it? Export Sprite. I don't even remember what I just called it. I'm pretty tired. The holidays are fun, but man, they are just exhausting with all the running around and place you have to go and things you have to do. Especially if you have big families or kids or both. It can get tiresome. Convert Sprite. Okay. Convert Sprite JSON. All right, so all we're going to do now is we're basically just going to load the sprite into current sprite. We're going to take our target file name. That gives us our sprite. And then we are going to generate a valid JSON file, which shouldn't be too hard. Text file handle. Let's call this Sprite JSON file. Create text file. This is Sprite JSON file, and then we will call this JSON output file, which means we need to actually define this here. And then JSON output file to so we copy that there, and then replace the extension with .json. So now we have an actual JSON file. What did I do wrong? Oh, max size. Okay. Can you help me answer a question for a while loop in C#? It's for school and I can't seem to get. I mean, you can post it. I can't do your homework for you, but I can try and help if it's a small thing. All right, so we've got our create there. So if JSON output file, no, what did I call it? Sprite JSON file equals null. JSON output file. All right, so we have a error message there if we can't create our text file for the export. All right, so system hooks, create text file. No, we did that already, sorry. System hooks, write text line. Sprite JSON file. We open our curly brace, close our curly brace. All right, what did we make the rest of our file look like? I don't remember. So our bounding boxes, our collision points is animated. Okay. So let's see. Let's start with is animated because that's the easiest one. So I'll just write is animated colon, and then what I want to do is I want to do this and just say current sprite is animated true, false, and we're going to write a line there, and that's our line. And then let's just write a generic. Let's just do a for our last property. We'll just put bounding boxes and leave it at that, and make sure that our code is working and that it is syntactically correct. And then take it from there. So this should be that, and that, and that's a line right, and that's good. And I'm missing my spacing. All right, so Sprite to JSON. Let's see what it did, if anything, other than overwrite my file. Okay. So that's what it generated. Let's go to JSON lint, which if you've never used JSON lint, it's a handy website to validate your JSON file. Okay. Basically a while loop that shows numbers divisible by 7 under 500 in a list box. I don't want you to do my homework because then I won't learn. I've looked pretty much everywhere for help. Just can't seem to find any, so I came here. All right. I mean, without writing the code, because it's pretty well defined, you want to... The answer will do your homework, though. Well, so Banchiku, what I was going to say is it's pretty well defined. You got two parts, right? You've got the while loop that counts up until you reach 500. And then you have numbers divisible by 7. So if you can solve each of those separately, you can solve the two together, right? So if you can write code that if you put a number, if you do a simple test with any arbitrary number you type in that tells you if the result of the number is divisible by 7, right? So it just prints true or false. That's the first part of it, right? Second part of it is, can you write a loop that will count from 0 to 499 and then stop? And then try to put those together. That's the best answer I can give you without doing your homework for you. I hope that helps. All right, so this, we're going to want to add the closing brace here because I'll be generating my bounding box information in between. So let's do this from 0 to my number of bounding boxes and let's do got a temp max file folder name. Okay, so temp and the format, let's see. So I forget what the bounding box is. Is it just it's 4 points, right? Bounding boxes. So it's an array of an array. Array. Malloc size. Number of bounding box size. 2. Oh no, wait, right. It's not 4. It's 2. It's 2 XY coordinates, obviously. All right, so what we're saying is it's X, Y, X, Y, and then we have our current sprite. And then, if I didn't do anything dumb, it will be I plus 1 here. And because we're doing that, we actually just want to do I plus equals 2. Oh, no. No, we don't. Why? What did I do here? Oh. Yeah, it is just a flat array, isn't it? Okay. So that yeah. So then this is times size of bounding box size. Is that what I called it? Bounding box size, yes. Bad sign if your boss all of a sudden starts emailing you detailing your one-on-one conversations. I don't know, it depends on what your one-on-one conversations are about. All right, so let's run that and see what that looks like. Should have a default bounding box, I think. I don't remember. Oh, yeah, well, I'm formatting the string. Never writing it. That doesn't help. Let's try that. Come on, Visual Studio. Are you running it, or are you just being difficult? Okay. The space thing is more of just trying to keep that organized. So, and then Actually, should this be an array of objects? Could do that too. We could say like that. Just so it's clear instead of it being just kind of a hodgepodge of integers. I think I'm okay with that. So that's good. And then let's see. Let's add the, we don't care about the width and height. It was the collision points. That was the other thing. And that is just an array of X and Y objects. The reason I'm doing this in JSON is purely just so that it's easy to modify without having to go through a lot of changes in the user interface, as well as being able to do things like once we export it, not even have to open up the UI tool to continue forward unless there's something that we want to visually see. So we'll see. We'll see if that actually pans out the way I expect it to, but we won't know until we actually start messing around with this thing in as we work on designing the game. What's the matter? Into vector B, current sprite collision. Oh, number of collision points, please. There are no collision points defined. Right. Okay. And that was because we had just converted it. So let's do this. Let's open this and define some collision points now. And save it. And then let's export that data. Cool. And then, so it's interesting, it's adding all of those 0, 0. Oh, those need commas at the end. Just like this will need comma at the end if there's more than one of them. What's the matter with this? Oh, comma there would be helpful. All right, so that's one thing that's kind of messy about doing this way. If I were doing this in C# or some other language that has better ability to handle the JSON input and output, what I do is, actually construct a class that, well, I'd have the Sprite class, right? And I'd make the elements that I want to export public. Maybe I'd have a special, like a derived class, an Sprite export class. I'm not sure exactly what I would do, but it would just be a class, right? And then you'd serialize it down to JSON and serialize and deserialize it accordingly. Excuse me, so that you don't have to be dealing with manually generating the text, it's not that big a deal. It's more just an annoyance than anything. But, you know, whatever. Did it for many years. Can do it for a little, you know, a little more. It's not a big deal. I know I said that already. If I plus 1 is equal, not equal to current sprite number of collision points. All right. And then what I want to actually write here is that. I want to write a comma. And that should be right line. So it adds a new line. I'm using a library in C called Jasmine, JSMN. It's pretty good. It's nice that it's C. It's pretty fast and simple. I was deliberately staying away from C++ just for, I don't know, for reasons, because realistically, it was more so just to kind of keep things straightforward, and I was just kind of excited about the idea of writing some just straight up C for a change, for better or for worse. So I'm sure there are JSON libraries for C. In fact, I'm sure at this point, let's see, I would be surprised if Boost doesn't have something in here for, there's a way to search for JSON. Let's see. There you go. So Boost has a JSON parser, looks like. We used Boost, and we also, actually, I take that back. We were using Poco at my previous job. It was pretty good. I thought it was pretty reasonable. I liked the way it was organized. I liked it had some decent functionality for things like SQL and ODBC and no, but you know what? We did use Boost because now thinking about it, there was some grammar and expression parsing stuff we were doing at my previous job, and we were using Boost's libraries for that. I don't remember which one it was now, but in fact, I wrote a grammar to parse and interpret the SQL grammar, SQL, because we were building a tool, a library, a layer for our product that required the ability to be queryable like SQL, but was not SQL. And so it required having something to do that parsing, and we hadn't found anything that really worked for us. So in the end, we wrote our own, or I wrote what we ended up using, which was not the easiest thing, but it was nice to have something where you could do it this way. It was nice to have something that let you express it as a grammar rather than a you know, writing the whole parser and interpreter yourself and all the stuff that goes along with that, which can be fun to do for just your own reasons, but it is time consuming to do well, and I don't recommend doing your own unless you have to for some reason. There are plenty of tools for that. What did I do wrong? So this is why, there's the close. Parse on error Y16. It shouldn't need a comma. It should just have that, shouldn't it? That one worked fine. Bounding boxes, open brace, open brace. Open object, close object. Oh, it doesn't need, it doesn't need the comma there. Okay, why are you generating a superfluous comma? Probably because I told you to, but let's see. It writes that line. Let's not do a write line here. It writes it out. And then it says, okay, number of bounding boxes times bounding box size. Oh, that's why. Times bounding box size. I think that'll fix it. Okay. So that's valid JSON at the very least. So we have, if it's animated, there are collision points, bounding boxes. If it is, excuse me. All right, so if it is animated, we need to have a, you know what we could do? We can change this to be a write line. If it's animated, we need to write the frame width and height, which we will in a second. I want to just kind of visually separate out these components so that they're easier to kind of see which ones are related. So if current sprite is animated, what are we talking about here? If it's animated, we just have an X and Y. So we can just call it frame size. I think will be good. So frame size, and then we will just do, we'll just write into this X colon our X, and then Y colon our Y, and then we'll close that, and we'll do a comma and a new line, and we have current sprite frame width, current sprite frame height, and we have that. Now that won't be used for the player ship because it is not animated, but if we do it for explode, we should get in explode.json, we should get, okay, so it did create the frame size. Oh, I did not output the actual, you know, just include this right in here. Probably the smart thing to do. And then we just write it once instead of doing multiple writes. Temp. In fact, we could probably just do that here as well now. And if it hasn't become abundantly clear at this point, I tend to go back and change code that I am not happy with as I work on it, which sometimes may not be quite as fast as just getting a bunch of stuff done and down, and certainly there's some benefit to doing things like that, but I feel like for something like this, the less code there is, the better, because otherwise it becomes a mess, even more so than it already is, very quickly. And especially things where we have code that we're copying and pasting a lot of, I do try to get rid of those things and refactor code, which again, in the short term maybe slows things down a little bit, but long term, again, the less code you have, the less opportunity for bugs or problems, etc. All right, so we have our animated working now, so that's good, and that was generating the right stuff for explode, so that's cool too. I'm trying to think if there's anything else we actually care about seeing. So let's see, that's good. All right, so let's go back to the structure here. Most of the rest of that stuff is going to be determined at the time that we load up the PNG. Or, well, so frame width and height, palette file name. I think that's okay for now. So now the fun part is when we do our PNG to Sprite, what we need to do is actually look for this file being passed. So if we do PNG to Sprite, shooter assets PNG, shooter PNG. I'm just doing full paths because I don't want to deal with if it's not finding it in the relative paths. All right, so we should get to this point correctly. So if argc is 4, I guess, yeah, I guess that would make sense, wouldn't it? All right. So let's say greater than or equal to 4, because if there's extra stuff, I don't care, but I don't want it to not pick up the target metadata. All right, so, and then that's this here. So what we're going to do now, all right, so, how are we going to, this takes the image and creates a sprite out of it. I think what we can do is we can, what are you sharing here? Sorry, I was just looking, I saw you shared a link to this JSON parser. I'll take a look at that later. That looks cool. All right, so I think what I want to do is I want to load the metadata into the sprite and then pass it into a sprite structure and then pass it to this. And if it gets the sprite, then it will use that as the starting point rather than just using a brand new sprite. All right, so here's how we'll do that. So if initialization memcopy new sprite initialization size of sprite. Now obviously we don't care about some of the, we don't care that the pointers are going to be copied over, but we do want to ensure that we are not overwriting them here. So if not initialization, initialization is such an awful parameter name. I'm gonna change that. What is, wait. Why? Oh, because it's writing it out. Well, I'll fix that. I'll get to that in a second. Initial data. All right, so if we have some initial data, we don't want to copy, we don't want to allocate more memory and set up a new sprite and a bounding box for it. New sprite dot bounding boxes. Okay, so we're just, this is just a holder. Yes, because we are creating the sprite and writing it, and then we're freeing the memory that we allocated. Okay, so let me put this over here, then move this here, and that pointer needs to get set. To new sprite dot bounding boxes, and also to collision points. This is because we don't want to serialize. We don't want to serialize our pointers because they're meaningless outside of this runtime scope. So no point in saving them off somewhere. Same thing with the image, it's going to get written. Collision points. Alright, so now this is going to write bounding boxes correctly. And then I think collision points is after bounding points, bounding boxes. So collision points, size of vector times in a normal initialization of a sprite, there are no collision points, and so the value will be 0, which means that this will write 0 bytes, which is fine. This is the image that it's writing, which is good. We will free collision points here, but only if not initial data. And the reason is that this function is not the owner of that allocation at that point. So we don't want it freeing it in case I decide to do something with it later, only to have a crash because the data is no longer valid because we're referencing memory that's been deallocated by this function. So, all right. I think that looks good. So now that's all that's left is the actual parsing of the JSON code. So let's get to that. So let's call this initial sprite initial sprite equals this. You only need to do that if target metadata 0 doesn't equal character 0, meaning it's not null, or it's not empty, I should say. So if we have, actually, we need that. We need that because, wait, do we need it? I'm going to call it 2 different ways. Oops. Come on. Call it over here. Oops. Initial sprite. And here we'll just call it without the parameter, just so that we have that. Load sprite metadata. And we're going to pass it the initial sprite and target metadata. All right, let's go define that somewhere, shall we? And we'll do it right over here. So now let's go grab our stuff from this, because I don't remember how this even works anymore. So we got to load our code and then run it through the parser and read all. Okay. All right. So I'm just kind of blatantly stealing all that code. Let's see. So this is the file that we actually want to open. Tileset file size is, this is a bad name. This is a metadata file. Metadata file, just return metadata file. Let's see. So we have our metadata file that we're going to open and read and load and parse, and then obviously we need to free this if JS code. Okay. So let's see now. Jasmine parse. So we got that parser working. Am I doing, let me see. Okay, no, so I'm not, I was originally looking at, if I open it, you know, making sure that I didn't have too few tokens in this buffer, but I think we'll be okay for the size of the objects that we're defining. So let's see. And then I have these helper functions here. So if we go back to our object JSON, the first thing I guess we would want to do is we want to get just for the sake of expedient or simplicity for starting point, although I don't think I actually wrote something to get a Boolean value from the JSON, but so let's see, get property value. What does this get? Property name index, it returns an int. Get token array elements byte, get property value as string. So let's start with that. Well, I don't really want that. Why can't I just get it as, I should just get it as a Boolean. Get property value as bool. JSON code, Jasmine token, tokens, int max tokens, const char, property name, property. Oh, I see. Yeah, let's keep this consistent. It's returning a value rather than, okay. Now, so get property value as string. It's getting it as a string and then it's parsing it. I mean, it should just be, this is going to be pretty much the same thing, except we're going to say property value, string compare, string case insensitive compare, buffer true equals 0, then it is going to be true, otherwise it is false. And that's that, and then we should just name this consistently. Okay, so load Sprite metadata, get property value as Boolean. So our code is this, our tokens is this, our max tokens is this, the property name is this animated, and current sprite is animated. Oh, no, it's not current sprite. What did I call it? I called it sprite is animated. Is that an actual Boolean? It's an unsigned char. Well, guess it doesn't hurt that we have that. Unsigned 8, uint 8. Let's make sure that that runs. No image. Convert image to indexed main. Convert PNG to Sprite. Okay, what? Target file name. Shooter PNG. Is the path wrong? Oh, yeah. Well, no, that's just the wrong file. It's player PNG. And player JSON. Okay. Should be happy now. All right, so that looks like that worked because it is animated. It was set to nothing, or to false rather, and it didn't crash. Let's do collision points. Get property value. Actually, how did we handle the arrays from? This is exporting the map. Let's see. That's the actual export load map. I don't remember how that worked. So Get property is string type. If it's a map, then get the property value. The token index for tile sets. Get property value. Doesn't equal Jasmine array. Doesn't equal token index. Oh, okay, right. Get property value. That's actually okay. That's why I was confused as to what that actually does. This is actually get property. Should be really called get property index, because it's retrieving the index of the property we're interested in. This case, collision points. Let's start with, shall we? Tokens, max tokens, collision points, and we need an index variable, which should be an int. So un32 index equals 0. Oh, int 32? Okay, fine. All right, so we have our index, and then that will give us the ability to look into the tokens and see what kind of thing it is. So what we need to do is we need to say, okay, if tokens index type is not a Jasmine array, right? Because it's got to be an array, because we have an array of these object things here that we want to get values out of. And it should also tell us the size. If the type doesn't equal and the size is greater than 0, shouldn't that be equal to 0? I would think. To do, is this right? Should this be size greater than 0 or size equal to 0? Seems like it should be equal to 0, but I don't know. I don't remember at this point. Get property index. We're back here. So if the array is that, doesn't equal this, and yeah, okay, that's fine. We'll return. Otherwise, what we want to do is we want to say number of collision. Actually, we'll just put it right in the sprite. Sprite number of collision points is equal to tokens index size. Let's see what that looks like. 3 collision points. And that's right too. All right, cool. Excellent. So now that we have that, let's see. How do we iterate through the objects? If I remember, there is. Let's see. So we're going to increment the index, and then we're going to find that it has to be an object, and then we're going to yes. Okay. Simple. Although I say simple now, but how do we get to the next index? We increment by the token size. Well, we'll see. I don't I don't exactly remember how that worked now. Because this is all the object stuff gets essentially flattened out into that token buffer. It's a little bit nasty to traverse at times, but that's okay. All right, so we have 3 collision points. So int I is 0, I is less than sprite number of collision points. And, oh, we need to allocate the memory to hold that information. So let's do that. Equals, what kind of type is this? Vector 2b. Vector 2b pointer malloc size of vector 2b times sprite number of collision points. All right, so we've allocated the memory for the collision points we're about to read out of this JSON file. So let's do the increment of the index, which gets us to the object. So we should see that if we ever get to a point where it is not a Jasmine object, then we want to return. Should probably do some better error handling here, but we can do that later. All right, so we have our Jasmine object, and now we just want to get our X and Y. So sprite collision points IX is what we want to store that into. So we would say get property value as int, no, uint8. So this is our code. These are our, is it just tokens? Yes, tokens. Except it's tokens in index. No, wrong place for the ampersand. Tokens index like that. Max tokens. Property name is X, and the property value is that. Except we need the address of that. And then we want to do the same thing for Y. This should say JS code. Y. Okay. So right now, oh, we never memsetted it. Oops. 70. Well, you know what? That's the right value, so that's pretty cool. Let's memset that memory, shall we? So that we don't have random garbage in here. 0 size of vector 2b times sprite number of size of sprite number. I don't know why autocomplete stopped working there, but whatever. Okay, so that's that. And then what we actually want to do, I believe, is we want to say index plus equals. Well, let's see what the object looks like, because I believe that's just going to have, the size of the whole object in the buffer. Size is 2. So if we look at this, we have index plus 1, tokens index plus 2. Oops. That's the first one there, and that's that one. Those are both 1, and then the next one should be our next object. Oh, it's not. It's the string. Oh, because right, it's it's the name and then the value, the name and the value. So it is the size times 2. Oh, right. Okay, that's why I'm doing the times 2, because it is a flat object with the parameters and the values. So index plus equals tokens index size times 2. Does that give me size is 4? So let me see this object parameter value plus 1. Yeah, it should be plus 1. Because that gives us the last value in the object, and then we want to go on to the next object, and that would mean that we should be good with our collisions now being loaded from the JavaScript. So let's take a look at that. Sprite and 70. Let's put this into memory. Oops. I was trying to make the text bigger, but I don't know if I can do that. So 70 and then 115, which is 1F, and then EF, which is 1415, which means that we were successful. Awesome. So that loaded that correctly. That's great. And then we are going to be at the next part of this, which now we want to grab the bounding boxes, which will most likely just be 1, but that's okay because we may have more at some point, bounding boxes. And we're doing the same thing here, same exact process. We are just operating on bounding boxes instead. So bounding box, number of bounding boxes is tokens index size. And then we're going to allocate memory for it. The difference being that when we allocate this memory, it's the size of the vector 2b times the sprite, number of bounding boxes times bounding box size, because bounding boxes are inherently going to be twice as big as collision points because it defines a top left corner and a bottom right corner. So let us initialize this accordingly. Oops, not that. Whoa, that was weird. Not that. This, please. Bounding box size. Okay. So that initialized it. We're going to go on to the next object, and then we are going to do the same. Well, no. See, it's a little different because now within the array, we have another array. Do I want to simplify that? I think I want to simplify that only because I really don't want to traverse an array of an array in this. And there's really no downside to doing what I'm about to do. I need the top of the for loop. Number of bounding boxes times 2. I plus equals 2. And so what we do is we are going to grab x1 and y1, and this should be for bounding boxes and not collision points. And then we're going to do x2 and y2, and this is purely just because it's much easier to do it this way with the helper functions we have than it is to do the traversal of an array. So let's just change that. And then we have our bounding boxes. So let's go back to where we are generating our JSON here. So let's just change this to x1, y1, x2, y2. Get rid of this part and make this. So an array of this object. So x1, y1, comma, x2, y2. Okay, and then we'll just make this change manually for this one for the sake of not having to deal with re-exporting it. Right, because that's functionally equivalent and much simpler. I like that. Okay. All right, so, and that's it. That should be our Sprite starting point here. So if we look at our Sprite, we should have one bounding box. We do. We have a number of collision points, 3. The bounding box is, let's see, so 0, 0, and it should be 16, 16. So if we load that into memory, 0, 0, 16, 16, perfect. All right, so we free our JavaScript code from memory because we don't care about it anymore. We're done parsing. So now we have our Sprite metadata here in initial Sprite. And now we're going to create the Sprite based on this initial data. So we're now going to copy this into new Sprite, which will now have all the data that we need, including the pointers to the bounding box and collision points, which is good. All right, so now we're just doing sort of the basic stuff that we did before. Oh, you know what we didn't do? We didn't do the frame width and height, but we'll save that for next time. I just want to see if this works. So we save off those pointers because we're going to null them out for the sake of our serializing the struct out to disk. Okay. Sorry, I was pausing here because I saw we were writing out the collision points, but then I was like, wait, how are we doing that? But it's this thing, so that's fine. So we had the initial data, so it's not going to free that because it came from here. We don't want to touch that. Okay, that looks like that worked. So if we now reload the Sprite that we had just essentially clobbered and recreated with our JavaScript, paste. Let's just take the Sprite that we just created and load it up. And it should have, yes, it's got our collision points. And now, look at this. We can say, you know, that's all well and good, but those bounding boxes, man, that's too big. Let's make this 13 and 13. And let's go back and re-export that Sprite. I assume that ran. All right, so then now that we did that, we should be able to see the bounding boxes changed. All right, so it partially changed. It did not. Did I? 13 by 13. Interesting. So what caused that to stay at 16? Load Sprite metadata. All right. And we'll want to do the same kind of thing with the meta tiles, but the meta tiles are actually much simpler to deal with because they just have the collision points. So we probably don't have to go through all of this for that. I wonder why x2, y2, bounding boxes. All right, let's take a look at what got loaded when I did that. So let's see. Sprite. So the bounding boxes 3, 3, and DD. Which, that's right, so it's something in the create sprite that is failing to work properly. So let's go here, and now this is called new sprite, and let's take a look at the collision points here. I mean, it's possible that it's just a rendering error, actually, that it's... Yeah, I think it's a rendering error because it looks like the bounding box is actually stored properly. So that's good, although I gotta figure out why it's not drawing the bounding box properly. Let's figure that out, and then we'll call it an evening. All right, so collision points are still good. The bounding box is drawing over to the side there, so let's see what's going on with our sprite here. Oh, if it's animated, is it doing this? No. Okay, that's weird. Otherwise, frame height is that. That part I knew was hard-coded, but I didn't think it was calling it, and it's not. All right, where is it drawing? Drawing bounding box here. Number of bounding boxes. So let's see what it's actually doing here. Oh, wait a minute. Oh! Oh, it's the width and height. Why did I do it that way? Hey, Zorchenheimer. It's going pretty good. Got some art we're working on, and getting the build to a point where we can get assets in pretty seamlessly. At least that's the theory. All right, so that's because that's a width and height, not a bottom corner. I don't remember why I did that, but okay. So that explains why it's doing this. So let's just say it's 10. All right. Let's go back to this, and we will re-export it with the new bounding box, and then reload it with the newly created sprite, and let's see what it does. Okay, that's what I was expecting to see. So now the bounding box is... I gotta look back at why that's a width and height instead of... two X and Y coordinates. It's not that big a deal. And in fact, what I'll do, just to avoid confusion right now, is I will actually name these width and height. I'm going to close this. X2. X2. just because I don't want to make this same mistake later. If we change it, then we'll change it. But that is, I'd rather have it be consistent and questionable than questionable and inconsistent and just confuse the hell out of me. All right, so, and then our collision points are good still. All right, so that's all good. And now in theory, I should be able to just export that out and it should work fine. Of course, the point is that this would all be done by a makefile and not me by hand. So let's go and look at the export here and load this into the game and rebuild. So that's, we don't need that right now. We don't need that right now. Let's rebuild this, make sure nothing got broken in this process. Eventually Messin will load. Okay, and there's the ship, and you can fire the bullets, and the motion is still the slow motion, and the attribute loading is working. And let's see if our enemy ships decide to grace us with their presence here in a moment. They do, and you can take them out. Great. And then let's make sure collisions are still working, which they should be, and they do. Excellent. All right, great. Making progress here. So the next step is that, okay, so we have, I gotta finish the process of doing this for the other sprites, but that's not that big a deal. So for like the explosion and the bullet and stuff like that, those will have these metadata files that we can use to export them from the command line and have all of those settings be correct. The next part is getting the ship together from the original stuff here. I'll show you guys what we've got here, because I'm excited to show it. At this point, I think it's... oh, do I not have it on here? Oh, okay. Well, let's fix that. Let me get the latest... sorry, I'm doing this on another screen here. Just... I'll download the files here for us to look at, and you'll get to see some of the background art, which we haven't incorporated into anything yet, but it looks pretty cool. Especially some of the animations that were put together. I'm really pretty excited. The challenge, of course, is now that we're working with someone who actually knows what they're doing with art, it means that I have to make it actually work with the art that's more than just programmer art. So yeah, so here are some of the ideas for the ships and enemies. Here is some background imagery, which looks awesome. Here is some animation stuff that was done. Bear in mind the color scheme of the other ship is too many colors. This is what we'd end up with. There's some animations here for actual battle stuff. Enemy engine blinking. Pretty awesome stuff. So I'm excited to get that worked into the code. And start having this be a little bit more than just me messing around with the tech. Making good progress, and what was I going to say? So as far as the design goes, I was thinking about how I'd like to start with the design, which is I'd like to start with the idea of that it should feel fast, but different in not fast in the way that shooters traditionally feel like hectic, more so fast in the sense that it feels like you're actually flying fast. And so it's going to be a challenge to convey that in the game in a way where it both feels fast, but you can actually do something like to destroy the enemies. I have some ideas of how that will look. We're obviously going to have to program things and change exporting as we do that, but that's kind of I think that's going to be cool to be able to do that in here. Yeah, so I'm excited for that for next stream. We'll get the is animated stuff done. That should be really quick because that is just this is animated. Is actually that part's already done. It's just if it's animated, we got to pull the frame size for the explosion, for example. And that's for just a sprite that has no animation tied to anything other than a timer. We'll probably have to start defining how that gets into the game besides the fact that it's hard-coded to the entity type. I mean, maybe that's okay, but I'm not 100% settled on that yet. And then I've been asked a few times about the source code, and I'm trying to think of a good way to make the code available through a GitHub repo as read-only. I will, at the beginning of the next stream, talk about my idea for that and what I plan to do. Yeah, so that's that. So thanks for watching the stream. As always, if you need to reach me for any reason, I'm on Twitter at Clairvis. I'm also on Nintendo Age as Elias in the XELIUS in the Discord and the forums and stuff like that. You can also email me. I have my email address while I'm programming. You can find that on the recording, which is on YouTube, which I'll post onto Twitter as soon as the recording is done uploading. That was like a chain of social media connections that was unintentionally all interconnected. Yeah, but thanks, and I will see you next time. Next week is, let's see, next week is Christmas on Tuesday, Christmas Eve on Monday, so we won't do any streaming Monday or Tuesday. I'll remind everybody on Thursday about that, but I'll probably stream Thursday. And then the week after that is MagFest. So if you're going to MagFest here on the East Coast in the U.S., I'll be there. A bunch of other NES homebrewers, it sounds like, are going to be there too. So you should definitely, if you haven't signed up, I think the prices change soon for it. I mean, they don't sponsor me or anything. I'm just trying to save you $10. But if you can go, you should go. It should be. I hear it's a fun time. So anyway, yeah, thanks again for watching, and I'll see you next time. Have a good night.